Hi, I'm Ann Stinnett. I'm the math specialist for the Knox County Schools, and this video is a support for our summer at home packets that are available for you to download and print on our website. These packets cover the major content of 8th grade math, and reviewing these and going through these over the summer will really help you prepare for your freshman year of Algebra 1. And I'm going to talk about the activities in Section 3, the proportional relationships and functions. If you've been following along the KCS at home videos throughout the spring, a lot of these concepts are going to be a review of those videos. You probably heard me talk about some of these already, but we're going to dive right in and go through the packet. I'm not necessarily going to give you all of the answers and go over all the problems. I'm going to do just a brief information that will help you complete the packet, and then you will have the answer keys so that you can check your work as you work on them. Of course, my contact information is right here on the screen, so if you need anything at all, you can contact me or your teachers. So in this packet, there are 4 activities, or this part of the packet. The first activity is representing proportional relationships, and we're going to talk about what that is and 3 ways to represent the relationship. In the second activity, we're going to be interpreting unit rate as slope. So we will talk about what is slope, what is unit rate, and how are they related. And then we're going to find unit rate from a graph and a table. The third activity is writing linear equations from a table. We're going to talk about how to find slope and y-intercept from a table, and then write an equation in slope-intercept form. The fourth and last section in this part of the packet, we're going to identify and represent functions. We'll talk about what a function is and how the input and output values identified in an ordered pair, how are they in a mapping diagram. So we're going to look at a specific representation of functions in that section. So section 1, representing proportional relationships. What is a proportional relationship and what are 3 ways to represent the relationship? So let's start by reviewing what a proportional relationship is. It is a relationship between 2 variables where their ratios are equivalent. So the example in your packet, we have a table that shows the number of cups of vinegar Martin needs to add to certain amounts of water to mix his cleaning spray. So take a minute and think about what patterns you notice in the table. You might notice that every cup of vinegar is increasing by 1 cup as we move through what we would call the X values. In the water, or the cups of water, it's increasing by 5. So you might notice a couple of things. These ratios, 1 to 5, 2 to 10, 3 to 15, and so on, are all equivalent. One number in the ratio, the cups of water, is always 5 times more than the other number, or the cups of vinegar. You might notice also on the graph the same thing is happening. For every cup of vinegar, the cup of water increases by 5. So we have 1 to 5, 2 to 10, 3 to 15, and so on. So on the graph, you can see they're equivalent not only by the values, but also because they run through the origin. It starts at 0, 0, and it makes a straight line. So that's another clue on a graph that we have a proportional relationship. The equation also, if y is the number of cups of water and x is the number of cups of vinegar, the equation for this proportional relationship is y equals 5x. In other words, the number of cups of water is always 5 times the number of cups of vinegar. So those are 3 ways to represent a proportional relationship. In a table, you'll see equivalent ratios. In an equation, you'll typically see a multiplicative relationship or multiplication. There's no initial value or starting value because on the graph always runs through the origin or 0, 0 and creates a straight line. So some guiding questions for Activity 1 to help you get through these problems would be to first look at the table and think about how the distance driven and the gas used values are changing. In other words, what patterns do you notice as you look through there? That will help you answer number 1. For number 2, once you get the table completed, it'll help you get started and think about what is happening in that ratio. If you were to divide each distance driven by the gallons of gas used, what is the quotient? Another way to think about this is if you were to treat these like they were equivalent fractions, what would simplest form look like? Not exactly fractions, but a way of thinking that might help. So if we're going to use division in number 2, think about how that relates to number 3. What operation is being performed to each x value, or the gallons of gas used, to get the y values, the distance driven? If you know that operation, that tells you what you need to do to x in order to get y. Activity 2 is interpreting the unit rate as slope. So our questions are, what is slope and unit rate, and how are they related? And how can I find the unit rate from a graph and a table? So here is your example. This is not the same one on your paper, but a rate is a ratio of 2 measurements, and a unit rate is a rate where the second quantity in the ratio is 1 unit. So here I have a table that represents the number of candy bars sold and the money received. So perhaps a fundraiser at a school. So if I sell 2 candy bars, I'm going to get $3. And if I sell 4 candy bars, I'm going to get $6. 6 candy bars for 9, and so on. So the way to write that rate is I could say I'm going to pay $3 for 2 bars. Now, if I were to do 3 divided by 2 to get my unit rate, it would be $1.50 for every bar, or $1.50 for 1. Now, you could interpret this the other way, like 2 bars for $3. I could do 2 divided by 3, and that means I get 2/3 of a candy bar for $1, or 67 hundredths about for $1. But we don't want to do that because that doesn't make sense. I can't come to a candy bar sale with $1 and say, hey, give me as much as this will buy me. Also, when we're looking at this graphically, the x is our independent value and our y is dependent on what happens to x. So depending on how many candy bars I sell, that's the amount of money I'm going to receive. So even though this second ratio is a unit rate, it does not make sense in this context. And that's the trick sometimes with rate and ratios, is the language or the situation that it represents is really important to getting it right. And it's a common mistake that sometimes we overlook when we're working with rates and ratios, is we always have to stop and think, does this make sense in this situation? So the second example, when we talk about slope, slope is simply a measure of steepness of a line on a graph. And to find it, it's the rise divided by the run. So if we look at the same candy bar table represented graphically, you can see here every 2 candy bars I'm going to make $3. So 2 to 3, 4 to 6, 6 to 9, and so on. All of those are equivalent ratios, and the unit rate would be how many candy bars sold, or I'm sorry, how many dollars for 1 candy bar. Now we have a discrete graph because I'm not going to connect these dots to represent candy bars sold, because again, I'm not selling fractions of a candy bar. But I'm going to use a line just to help me see where on the graph I might find that unit rate. So if I look here, that 1 candy bar sold, it looks to me like it's right at 1.5. Again, the graph is probably not the best way to find a unit rate in this situation, so I'm going to need to divide. You could do either way depending on what your problem tells you. But the work in your packet, it's going to be hard to see the answer on the graph. So you're going to have to divide to find the actual unit rate. So your guiding questions for activity 2. For number 1, look at the graph and try to process what it says. Which axis shows the hours and which shows the inches of rainfall? And how are those 2 values related? Because you're going to be asked some questions about what is happening in the graph and the amount of time elapsed and the inches of rain that has fallen. So for number 2, what operation do you use to find the unit rate? It will help you in getting an exact answer for number 2. And number 3, to find the slope of the graph and the unit rate, think about how many inches of rain fall per hour. That's going to give you your slope and your unit rate. The second part, you can use the table to answer the questions, but number 7 specifically asks you how you know. But think about in the table, what do you notice about the unit rate? And that'll help you create an answer for number 7. Activity 3, writing linear equations from a table. How do I find the slope and y-intercept from a table? And how do I write an equation in slope-intercept form? So let's start with our key vocabulary. A linear equation is exactly what it is, an equation whose solutions form a straight line on a coordinate plane. We typically write those in y equals mx plus b form. So that's always a clue that you're looking at a linear equation. So in that equation, the slope, or the rate of change, is represented by m. So here in this red line, the slope is 1/2, or 1/2. That means the rise over the run. We're going to rise 1 unit for every 2 units we go over on the x-axis. And then the b value represents the y-intercept. So for this red line, that's at 2. The line crosses the y-intercept at 2. For the second line, you might notice it's a negative slope, so it's going the opposite direction in a negative direction. There's no coefficient written in front of the x, so that means it's 1. So -1 is going to go down 1 for every 1 that it goes over. And it crosses the y-axis at +5. So there's your y-intercept. So we're going to practice writing equations in this form in the section. So another way to think about slope, or rate of change, and again, we just talked about slope being the steepness of a line, but to get more formal or more exact, it's a ratio that compares the amount of change in the y values to the amount of change in the x values. So here we have a graph. It's a non-proportional graph, but we can see the rate of change in y over the rate of change in x gives us the slope. You may have seen a formula similar to this, rise over run, the change in y. So in this case, y2 minus y1. So here we have y2, the y value here is 7, and here the y value is 1. 7 minus 1 is 6. And then we take that over the difference of the x values. The x value here is 5. Here the x value is 1, and 5 minus 1 is 4. So we have 6/4 as our slope, and we generally write that in simplest form. So the slope is 3/2. Again, sometimes you can find that on the graph with the proportional graph, but in this case, we're going to use the equation to find the exact slope. So in your packet for the example, you are looking at the hours it takes to repair a car and the total cost of the repairs, including the cost of the parts. So when I look at the table, in order to find my y-intercept, I want to know where x equals 0, because if I graph that, wherever x equals 0, that's where I'm going to cross the y-axis. So here on the table, when x is 0, y is 325. So what that means is, if I take my car to this repair shop, before they've worked on it at all, 0 hours, I'm going to pay $325. That tells me that the cost of the part is probably $325. So no matter what they do, I'm going to at least pay that much. And we call that in our equation not only the y-intercept, but the starting value or the initial value. So you'll notice here where x is 0 in my equation is where b is represented. So now I need to find my slope. I need to take the difference in the y values. So you'll notice here, you might have noticed just looking at the pattern, that's great. If I'm not sure, I want to double check, then I can subtract 625 minus 525, and that gives me 100. Now typically you want to make sure that's constant, but we're going to take our word for our packet that they are using a constant rate here. And then I'm going to do the same for my x values. 6 minus 4 is 2. So the slope is 100/2, but we want to write that as a unit rate if we can in simplest form, or 50/1. So my slope is 50. And in my equation, that's where I substitute for m. So the equation of this line is y equals 50x plus 325. What that means is 50 times the number of hours. The mechanic is making $50 for every hour he works on your car, plus the initial value or the initial cost of the part. For activity 3, you're going to be practicing this on a couple of problems, just what we went over. So for both of the problems, think about what the difference is between the y values and the x values. That will help you determine your slope. To find your y-intercept, look on the table for where your x value is 0, and make sure that your equations are written in y equals mx plus b form, where m is the slope and b is the y-intercept. For activity 4, we're going to identify and represent functions. We're going to talk about what is a function and how are the input and output values identified in an ordered pair or a mapping diagram. So we're going to look at both of those. So starting with a function is simply an input-output relationship, but to be specific, it has exactly one output for each input. So in order to be a function, I cannot have one input producing two different outputs. So on the screen you have an example and a non-example. So this first one is a function. For every x value, there is one unique y value. And you might notice in this table there are some patterns. As x increases, y is increasing as well. Y is doubling. So for every x, y is 2 times that. So 2 times 2 is 4, 3 times 2 is 6, and so on. In the second table that is not a function, you'll notice that the x values have more than one y value. So here we have 1 with an output of 2, but we also have 1 with an output of 5. That tells me that this one is not a function. In a mapping diagram, it simply looks like this. This is the one on your paper as an example. But you can also see for every input on this first one, there's exactly one output. Now here we have 2 outputs, but they have 2 different inputs. So 1 only has one output, and 3 only has one output. So that's okay, and that can get a little tricky about getting some confusion about what a function means. Just remember, every input has exactly one output. So here's your non-example. Again, in this case, the input of 1 gives you 2 different outputs, and that tells us that this one is not a function. So your guiding questions for this one is, where would you locate the x value in an ordered pair? When you have your parentheses, it's typically x, y. Where do you find the y value? So you're going to be underlining the, let me make sure I get this right. You're going to underline the output and circle the input. So that's really just looking for circling the x value and underlining the y value. And then for the second part, make sure every input or every x value has only one output or only one y value, and you'll do great. So to recap, the 4 activities in this section of your packet will help you be better prepared to understand proportional relationships and functions as you go into Algebra 1. We looked at representing proportional relationships. Hopefully you can answer what that is and 3 ways we represented it in your practice. Number 2, interpreting unit rate as slope. We talked about what that was and how they are related and how you can find unit rate from a graph and a table. And now you know sometimes it's easier one way than the other, and that's okay. Number 3, writing linear equations from a table. How do you find slope and y-intercept, and how do you write that in slope-intercept form or y equals mx plus b form? And finally, what is a function? How do we look at those in an ordered pair and a mapping diagram? So thank you so much for doing some math with me today. I hope this has helped you reinforce your 8th grade math skills to make you the best student you can be when you get back to school in the fall, and I look forward to hopefully seeing you then.